Okay, a similar problem for number 2. We are going to graph the region bound by these three equations. The first one is horizontal. The second one is vertical. X equals 0 is the same as the y-axis. And the third one is in point slope. So the first thing you have to do is figure out the point. The point is going to be 4, because that's what's behind the x with the opposite sign. -1, that's behind the y. So we're going to graph that point, which is right here. The slope is -3/4, which is down 3/4, or up and to the left. So we're going to go 1, 2, 3 over 4. That's right here. So we're going to have this shape. And let's erase the lines we don't quite need here. I need that to be a huge point. And so we have a right triangle right here. It does ask us to revolve around the y-axis. Of course, you know the y-axis is also x equals 0. So 2 of our points are on it. It's just our third point. We have to count over 4. And then we're going to connect when we revolve. Remember, this is going to be three-dimensional. So to give it that three-dimensional feel, I'm going to put some arcs in here. Okay? Not the prettiest cone you ever saw, but you get the idea. So that's a cone. It does ask us to find the cross-section. So if you can imagine you have a cone, you're taking a plane, so like a piece of paper, and you're going to actually insert that plane at x equals 0, which is actually this yellow line right here. So you're putting a plane in at that yellow line. Okay? Now, what you want to think about is right here. When we insert a plane right through the center, and this again is perpendicular. It's perpendicular to our base. So it's going to take on the shape before we revolved it. Okay, or like the shape as I revolved it before I put in the 3D figure. So if you can look at this a little bit, maybe I can go this way. It's just that triangle. That triangle fills up that whole thing. I can't turn it all the way. Maybe I could do, no. That's not it. That's not it. There we go. So I hope you see that it is a triangle that goes from side to side, taking the whole base up, and has the same height as the cone. So if we go back to our example, and I'm asking you to sketch the two-dimensional, it's this right here, this whole thing, before I put in the 3D part. It goes from side to side of the cone, has the same height. Wow, that's ugly. Has the same height as the cone. And we are asked to find the area of it. A little bit better. So here's the height. The height is 1, 2, 3. The base is from here to here, which would be 8. And if we calculate the area, we get 12 square units. Okay, and you can play around with that, this a little bit. These links are on your slides, so if you want to check that out, you certainly may.